Astronomers announced the discovery of water on the moon, and we're going to learn more about it starting right now. Welcome back to Launchpad Astronomy. I'm Christian Reddy, your friendly neighborhood astronomer, and in this video we're going to talk about water ice that's been discovered in the bottoms of craters on the moon. The water in the craters are located near the poles of the moon, and this is important because at this location the sun angle is always very low. That means that sunlight never directly hits the bottom of the craters, and the temperatures in these regions never rise above minus 163 degrees Celsius. For this reason, these locations are called cold traps, and it's inside these cold traps that water ice was detected. Now, water has already been detected in the cold traps of planet Mercury and dwarf planet Ceres. However, there haven't been direct observations of water on the moon's cold traps until now. Now, the whole idea of water on an airless world is still pretty strange. After all, daytime temperatures on the moon reach 100 degrees Celsius. That is, by definition, the boiling point of water. And because the moon doesn't have an atmosphere, ultraviolet radiation from the sun would easily break apart the molecular bonds of hydrogen and oxygen, and they would just escape into space because the moon just doesn't have much gravity. So finding water on the moon means that you've got to go looking in locations where it can remain frozen solid as ice. And that's where these cold traps come in. They're plunged into perpetual darkness, and any water that ends up inside them is trapped. But how does water get inside a cold trap? Well, water comes to the moon the same way it came to Earth, delivered by asteroids and comets coming in from the outer solar system. Now, water has been detected on the moon before, at least indirectly, and sometimes there was always a chance that the hydrogen and oxygen didn't so much represent water, but represented something else, like hydroxyl. But this time, the observations are direct and definitely show the signature of water. The team used data from the Moon Mineralogy Mapper, or M3. M3 is a NASA-built instrument that hitched a ride on India's Chandrayaan-1 spacecraft. Chandrayaan-1 launched to the moon in 2008 and observed the moon for about a year before losing contact in 2009. Still, that was enough time for M3 to sample the entire lunar surface, including the polar regions. M3 is a spectrometer, and what that means is that it takes light and spreads it out according to its color or wavelength. M3 was measuring infrared sunlight reflected from the moon. Infrared is important because water has a tendency to absorb certain colors or wavelengths of infrared. That means that if there is a sample of soil, there should be no absorption of infrared at these wavelengths. But infrared light coming from some of the cold traps showed the unmistakable signatures of water absorption. Now, you may be wondering how M3 can detect reflected sunlight coming from cold traps when, by definition, the sun never directly shines there. However, sunlight does reflect off of the crater walls, which in turn reflect to the bottom of the crater and up to the spacecraft. So it's a very tiny amount of sunlight, but it is enough for M3 to make some remarkable findings. First of all, it found that most of the water ice exists in cold traps within about 20 degrees of the moon's two poles. Also, most of the ice is located in the moon's southern polar regions, and that makes sense because the craters down there are larger and deeper. But what's really interesting is that of all of the locations where water could exist, ice was only detected in about 3.5% of all of the traps. And not only that, but the craters that actually did contain ice were older than about 2 billion years. That's very interesting and tells us something about the history of the moon's formation. You see, about 3.5 billion years ago, the moon underwent a period of heavy bombardment. Massive asteroids smashed the moon on one side, liquefying its interior as it erupted as molten lava. That lava distributed itself to form the Maria that we see today, but it also had the effect of hollowing out one side of the moon's interior. This caused the moon to wobble a little bit, and it's starting around 2 billion years ago, new cold traps began to form, but maybe there just hasn't been enough time for ice to accumulate there. But there's something else that's really cool about the story. Water is used to make rocket fuel, but getting water off the Earth is very difficult and very expensive. Lifting it off the moon, on the other hand, is quite a lot easier. That means that our nearest celestial neighbor can serve as a fuel depot for potential human expansion into the solar system. It's nice to know that there is yet another reason to go back to the moon, and I hope we can do that someday soon. By the way, speaking of water, did you know that they discovered water in a lake underneath the surface of Mars? Oh, and speaking of moons, did you know that they found 12 new moons around Jupiter? I'll have links to those videos in the description below. And if you have any comments or questions or anything you want to say, please let me know in the comments section and I'll be sure to check them out. And if you'd like to join me on this journey through this amazing universe of ours, well, please make sure to subscribe and ring that notification bell so that you don't miss out on any new videos. Until next time, I'm Christian Reddy, and keep watching the skies. This is direct detection of water at the bottom of the moon. Oh, damn it.